Okay. All right. Yep. And then.
How much does it work?
It's pretty heavy.
So
It's not one of the really
you
big
can come to about
ones,
here.
but it's still.
Okay, that's as far over as I can go.
Yep.
If I need to point to
You're
something.
writing a report and then
That's fine.
Oh, yeah, that'll work.
Like there are some like.
All right, Okay, I'd like to get started now that we've got things set up. Today we have Dr. Norris here from the Minnesota DNR here to talk about impacts on wetland hydrology here in the state. So we're looking forward to hearing what Dr. has to say. Tracy just reminded me that I should invite anybody that wants to go over to room 186 in the hall after the seminar. There's some goodies over there or something like that. So, anyway, you're welcome to come over.
All right. Thank you, Dr. Niebuhr. So I'm Doug Norris. I'm the Wetlands Program Coordinator at the Minnesota DNR in the Division of Ecological and Water Resources. I appreciate the opportunity to be here today. So this is the title of my talk, Addressing the Impacts on Wetland Hydrology. It's kind of a broad title. And in fact, there are lots of things going on that are responsible for messing up wetland hydrology out there on the landscape. But today we're going to focus on groundwater and some effects from groundwater appropriations, impacts on wetlands. And we're going to start by giving some background on the problem with groundwater appropriations. We're going to review some kind of basic wetland science and some hydrology. We'll get to the intersection of those two and then talk about some things that the DNR is doing to address issues associated with groundwater impacts on wetland hydrology. So hopefully this will work. There we go. All right, to just kind of frame, I should mention that feel free to ask questions as we go along. If we get bogged down, we may have to plow ahead, but you know, if you've got questions, feel free to pipe up and we'll try and address this as we go along. So just to frame the problem, first of all, Minnesota is very wet. This is a screenshot from our recently completed update of the National Wetlands Inventory in Minnesota. And it's kind of compressed at this scale, but basically everything that's not white on that graphic is wet of some kind or another, a lake or wetland, whatever. More than 10,000 lakes. We got 14 million acres of wetlands according to our new count, and parts of the state have very rich groundwater resources. But despite the fact that we have a lot of groundwater, we are beginning to encounter some conflicts with the use of that groundwater. This is just some newspaper articles, sort of some fairly recent, fairly well-known issues associated with the groundwater, the White Bear Lake issue, where White Bear Lake got drawn down for different reasons. And then recently, some folks wanted to drill some wells in southwestern Minnesota and ship water off to the southwest. So we're beginning to encounter some conflicts with what supposedly are our very abundant water resources. Oh, what did I just do there? Bear with me here. Put my glasses on. There we go. Hang on, I'm seeing a different screen than you are here. Well, we'll see what happens here. I'll just have to work off of this, I guess. Yeah, it's not wanting to advance. Yeah, that next one there. Sorry about this.
I think it's no longer.
Is it just frozen?
No, it's no longer in the mode
Oh.
presentation.
Maybe it is frozen up. Maybe we need to just restart it.
You just go to
There
your.
it is.
Yeah, okay. All right. Sorry about that. All right, so just to frame the problem a little bit better, this is a map of community supply wells, water supply wells for drinking. It's estimated about 75% of people in Minnesota get their water from wells. But maybe of more concern are wells for crop irrigation. And this is a map that shows the existing authorized wells that are out there. The size of the circle kind of indicates the amount of water that's annually available that can be appropriated from those wells, and those are millions of gallons per year that you see there in those figures. And the incidence or the amount of irrigated cropland has increased dramatically. Over about the past 40 years, the acreage of irrigated cropland in Minnesota has almost doubled. So we get almost a couple hundred of groundwater appropriations, irrigation applications each year. So that's creating obviously some potential problems with impacts on wetlands and other surface waters. And so just to illustrate why this is a problem, this is probably nothing new for any of you, but in a normal situation, you have a superficial groundwater table illustrated by the dotted line. That's supporting a wetland. It supports streams, it supports lakes. When you sink a high capacity well in there, start sucking water out of there, you get a cone of depression, and it pulls the water right out of the bottom of that surface water resource. So that's why it's a problem. Now, if you do one well, maybe not a big problem, but if you stack a whole bunch of wells together, as you see here, you can see where that might start to create some impacts on this wetland complex there to the south. And in fact, here's a real life example of a situation where we had, I'll use my handy pointer here, we'll go old school, where we had a landowner put in a couple of irrigation wells adjacent to a DNR regulated wetland in this case. And we have a well put in the wetland to track water levels. Well, take a guess as to when he turned the pumps on that well. So the end result is that it dried that wetland up. So that's just an example of the situation when what can potentially happen as a result of these groundwater conflicts. So in 2015, the legislature passed a bill that required the DNR to study the effects of groundwater appropriation on surface waters. And in fact, it required us to develop recommendations for defining what is a negative impact to surface waters and what are the thresholds for that would trigger regulation of those impacts. By surface waters, we were talking lakes, streams, and wetlands. And so we're going to focus today on the wetland aspect of this report. We did complete the report. We submitted it to the legislature. If you're interested in that, it's out there on the DNR website. So, wetland background, some basic review of wetland science here. Probably all of you are aware that Minnesota has lots of different types of wetlands, ranging from your classic duck marshes to shrub swamps, wet prairies, forested wetlands, both deciduous and coniferous. We have floodplain forests, bogs, and fens. So all of these different different wetland types have different characteristics that influence their plant community. They influence the type of fish and wildlife habitat they provide. They influence other benefits like the flood reduction and water quality functions of wetlands. So what makes one wetland look like this forested wetland, and what makes another wetland look like this calcareous fen? Well, there are obviously a number of factors here, but one of the main drivers, in fact, probably the driver, is hydrology. When we talk about wetland hydrology, we're talking about the depth, the duration, the timing, the frequency, and to some extent the source of the water that is creating inundation or saturation in that wetland. Hydrology influences soils by affecting the amount and type and the composition of organic material in the soil. It affects chemistry by the redox potentials, which in turn affects the amounts and kinds of dissolved minerals in the soil and in the water. Plants are affected. Different species of plants have different tolerances for being wet, and habitat. So some species of wildlife have fairly specific requirements for hydrology. For instance, amphibians. Many amphibians require that the wetland be inundated, have standing water for a period in the spring long enough for their eggs and larvae to mature. Then typically the wetland would dry up to prevent prey or predator species like fish from persisting in that wetland. So all of these are interconnected, but hydrology is the main driver for for influencing different wetland types. When it comes to the source of the hydrology, there's kind of a continuum between wetlands that are very reliant on groundwater, like calcareous beds, are completely reliant on a constant upwelling source of groundwater. On the other hand, you can have these ephemeral basins like this basin here that mostly relies on snow melt and precipitation. So you have things in between, but for the most part, and particularly for permanent wetlands, there is some reliant at least on superficial groundwater, and often, or in some cases, on deeper aquifers. So source of groundwater. Again, this is probably nothing new for you, but we can represent the hydrologic regime of a wetland, any water body for that matter, but for wetlands with an annual hydrograph. And this illustrates those hydrologic factors: the depth, duration, timing, the frequency of inundation and saturation. And the different wetland types have distinctive hydrographs, or they can have distinctive hydrographs. So for instance, a floodplain forest like this blue one here, the groundwater or the water in that wetland is typically below the ground surface for much of the year. It goes up in the spring during flooding and comes back down like that. On the other hand, you might have a wet prairie or a fen that has a very constant saturation at the ground level. So these annual hydrographs can be very useful for illustrating the hydrologic regime of that wetland, which again is driving a lot the characteristics of the wetland. So back to our legislative report, our negative impacts report. Given the variation in wetland types and the variability in hydrology, we got to thinking, well, how do we identify what is a negative impact when you have a groundwater appropriation? How do you identify and quantify a negative impact on these wetlands? So we start looking at some existing statutes and pulling some things out of there. And these are just some things that kind of popped out as this is from the groundwater statutes. It says that the groundwater appropriation, the proposed use will not harm the ecosystem. Under the Wetlands Conservation Act, it says that wetlands must not be drained or filled. So drainage can include sucking water out of the bottom from a groundwater appropriation, wholly or partially. So that's part of the statute. The impact definition of the wetland conservation is any loss in the quantity, quality, or the biological diversity of the wetland. So we thought about that for a while, and for the purposes of our report, we eventually settled on a definition of negative impact, which says that if you've got a groundwater appropriation that causes a loss of wetland area or a change in the hydrology that's sufficient to alter that characteristic long-term wetland plant community, or in other words, has the effect of changing that type of wetland, we were going to consider that to be a negative impact. So that's what we put in the negative impact report. So from there, we had a bit of a complicating factor. So the different wetlands can have a distinctive hydrologic regime, but some wetlands have a lot of variability within their hydrology. So for instance, marshes have a lot of variability. They have maybe a distinctive shape to the annual hydrograph, but there's a lot of variability within that shape. And so that created an extra layer of complication for how do we account for that extra variability when we're trying to figure out, well, what constitutes a negative impact. So we got to looking around again, and we eventually ran across a report from some folks in England who were looking at a similar problem. And they had developed what they call eco-hydrological guidelines for wetland plant communities in England. And we thought that that was a very useful model that we could use. And what they developed was what we ended up calling target hydrographs. And so instead of illustrating the hydrograph for a wetland as a single line, the target hydrograph, that this approach that we used, or that we wanted to adopt, looks at a range of conditions that the hydrology of the wetland exhibits over the year. So rather than a single line, it looks at the range of conditions that can vary over periods of time. And so for now, we're going to call this kind of, the green zone is the good or the normal range of hydrology for that wetland over the period of the year. You can have the wetland drop into what we're calling a fair condition, and this is where wetland, the water level drops. It creates some stress on that characteristic plant community, but the wetland it does this on its own. This is a natural variation for this wetland, and this is just an illustrative example. This isn't an actual target hydrograph. On the other hand, the wetland can occasionally get the water level so low that is under severe stress, and we're calling that bad for now. We'll put some different labels on this later. But these are conditions that the wetland will occasionally go into under extreme drought, and these are natural variations that the wetland will exhibit. So this is this target hydrograph approach. So yes, go ahead.
Yeah, so you said we could ask questions.
Yes, absolutely.
How would you, this represents a temporal variability, let's say over years, that you could have high, like what you showed, the very upper part of that, but
Right.
it could go lower because of just natural variability. I'm wondering how you derive that for a particular type of wetland or a given location.
We'll get there. So yes, go ahead.
Yeah, I was just wondering how long the unit has been working on this target hydrograph approach.
We started looking at this about 3 years ago.
Okay.
And as with most things in state government, progress is slow. But at the end of the talk, we'll talk about some progress that we are making. But the actual being able to do a really good job of this is a ways off, perhaps. But one thing I would mention on here is that there are yellow and red bands above the green. Okay? Certain wetland types can have too much water. But because we're in the context of talking about groundwater withdrawals and drawdowns of wetlands, things that reduce the water level of the wetlands, we're only going to deal with the red and yellow bands below the green. But just recognize that you can also have red and yellow above the green. So there's a question about how we develop these things. A useful way to think about this is, or a useful tool for addressing or developing these target hydrographs, are percent exceedance curves. And this is an example of some percent exceedance curves for lakes in Minnesota, and they are useful in identifying not only the ranges of elevation that the water level can go through, but also the amount of variability. So for instance, if we take, say, this red line, it's Edward Lake, which I have no idea where that is, but you can see that Edward Lake ranges from around 2 feet below its run out elevation all the way up to 2 feet, almost, well, 1.5 feet above its elevation. So it has a fairly variable range of water levels. On the other hand, if we take this black line, which is Lake Osawatomackie, it has a fairly narrow range of variability in that lake. So these can be useful in developing the target hydrographs for wetlands if you have data. And you might recognize this theme as I go along here. But we can develop, if we have long-term data, either long-term data for a single wetland or perhaps lots of data for a number of similar wetlands in different landscapes, in different areas, you can develop these same exceedance curves for the wetland. And for our purposes, because we need to be looking at the seasonality and to develop an annual hydrograph that accounts for seasonality, we would want to develop these exceedance curves at different points during the growing season. But for example, this could be an exceedance curve for a particular type of wetland that would have pretty variable water levels. Okay, it ranges from, I don't have a scale on here really, but it ranges from significantly below the ground surface to significantly above the ground surface over long periods of time. On the other hand, you could have another wetland similar to those lake exceedance curves you saw. You can have another wetland that has very little variability. And so here's where this comes in handy in terms of developing these target hydrographs. So let's take that first curve. Let's say you've got a wetland that exhibits quite a bit of variability. Let's say we want to look at the middle 50%. So this wetland, this is where the water will be between 25 and 75% of the time. It's kind of the middle range of its hydrologic conditions. So you draw these lines up that correspond to the 25% line and the 75% line, the 50%. And then you can just extrapolate that over to the elevation. So I'm not supposed to move over there, like go off camera. So you can extrapolate that over to the elevations, and that would give you that green band. That's the normal water level that wetland exhibits over long periods of time, or at least that type of wetland exhibits over long periods of time. And then because, again, we're worried about drawdowns, we're worried about water levels going down, we move out then to say we could pick whatever we want. Let's say we're going out to the next 15%. So we've gone from 75 out to the 90% exceedance level. So this then would correspond to the yellow zone where we're getting to having some stress on the wetland. And then again, you can carry that out to the lowest water levels, and that would correspond to the red zone. So by having a bunch of these curves at different times of the year, so you do it bi-weekly, you'd have to have the data, throughout the year. You could say pick monthly, bi-weekly, you would put them together on a graph, plot all those out, and you would end up with one of those target hydrographs. So this is a wetland that has fairly variable water levels. You can imagine now if we start with the one that has very narrow range of variability, you can see what happens if we do the same exercise by picking the middle 50% and then moving down the curve, what happens to those zones. So these then give you, I think this is just an example, so this isn't really plotted out, it's not using real data, but this would be an example of a type of a wetland that has variable water levels, a deep marsh, and it would have a fairly broad green zone, and that might vary depending on the type of the year. Again, this is based on developing those exceedance curves for different times of the year and connecting the dots there. On the other hand, you could have, say, a wet prairie or calcareous fen that has very narrow range of water level variability. And the way we envision using this is that if we know what these normal ranges of water level are, we feel like that can give us a clue for how much can we allow irrigators to appropriate that would affect these water levels. So for instance, if I go back up here, a lot of the irrigation that we see occurs in late summer. So let's just say we pick August, and let's say that's a 15-inch range. That this deep marsh, a typical deep marsh, might have a normal 15% or 15-inch range of conditions in the green zone, okay? It occasionally goes into the yellow and occasionally goes into the red on its own. But we know that it has, on normal conditions, there's at least a 15-inch range that it exists in. So we could take some amount of that. So we could take the whole amount, but let's say we want to be conservative. We could say, let's take half of that, and we would allow somebody to appropriate water that would take 7.5 inches off of that wetland in August. And we would allow that to occur really regardless of where it is in any particular year, because naturally undergoes this kinds of variation. Now, we might want to limit that if we're really having a long-term severe drought, because we don't want to be driving it down into that red more frequently than it normally does. But you've got to understand, you might be starting with the water level elevations up here, because again, there are green and yellow bands, or red and yellow bands above the green. So we can pick some range within that normal variation, and that's the point of this, is to give us some idea of what is the normal variation at different times of the year. It gives us a clue as to how much water we want to allow people to draw off of that. Now, part of the problem is, in order to do that, there has to be some modeling done. So our water appropriations folks can, given if they know enough about the geohydrology, they can model from a given well what's the likely impact on a nearby water body. Sometimes the resolution of that may not be sufficient for us to be able to use this approach. Sometimes we may not have the data to do that. We may need to do pump tests, and we do that occasionally. We'll require them to put in a well, do some pump tests so we know what the effect is. But the idea is that if we know what that amount of variation, it gives us a better idea for how much can we allow to be drawn off of that before we incur a negative impact that would require us to shut that irrigator down. Okay, so one of the big problems is, well, there's a few problems here. One is it's difficult the whole approach depends on having data to develop these target hydrographs based on knowing how wetlands normally behave, okay? We're finding that it's challenging to find in wetlands in Minnesota that are normal anymore, particularly in the southern part of the state. There is so much human disturbance of hydrology, plants, and everything else that a normal wetland is hard to find. So we'll talk a little bit more about that. The other thing is it depends on, if we're going to apply this in the future, it depends on basically having kind of a static picture of hydrology and climate. And as we all know, things are changing. And so what the normal hydrograph, what the normal target hydrograph for a particular wetland looks like now may be different in the future. And so that's kind of a wild card that we're faced with. The other biggest drawback to doing these target hydrographs is that to do them objectively requires long-term data on hydrology, and we don't have that. We just simply do not have the long-term hydrologic record for different types of wetlands as we do for lakes and streams. So consequently, we have designed and begun to implement a long-term wetland hydrology monitoring program. This is the scheme that we've come up. It requires 60 different monitoring sites encompassing a range of wetland types. And you can see that we've divided into we illustrated the wetland type in 3 different ways. And then it's also stratified by geography in terms of ecological province. So 60 different types or 60 different monitoring installations, monitoring wells installed in a bunch of different type of wetlands with basically 3 replicates for each kind. We applied for a grant and received a grant from the US EPA for about 20 wells. And we've also applied for to the LCCMR, the Legislative Citizens Commission on Minnesota Resources, to get money from the lottery trust fund for about 30 or 40 more wells. So we have money coming in to do this. And so we've been out actually this last summer trying to identify sites to install our monitoring wells. And again, we're looking for reference wetlands. We're looking for least disturbed types of wetlands that, to the extent that we can find them, are representing natural hydrology and natural vegetation. So we're installing wells We'll do some vegetation analysis to establish baselines, and we'll continue to monitor those on into the future. So that's one of the things we've learned, as I mentioned previously, is that it's hard to find these reference condition wetlands. We're focusing on public lands. We're trying to find ones that are interior to public lands, so we try to minimize the outside influences, particularly groundwater influences. One of the other things, as an aside that we've learned, is that you cannot always trust Google Maps, okay? So far, we've identified, I think, about 16 different sites, and we've installed wells. That's just a map of where we have installed wells so far. We've been focusing on wet meadows, deep and shallow marshes so far. And we have them, we're working off the EPA money, so we have money for about 20 wells right now. We'll receive the LCCMR money next July, and then we'll begin to branch out into the rest of the state into different wetland types. Here's an example of one of our typical installations. This is a control panel. We're using a bubbler system right now. If you can see it, there's a conduit that runs out of this panel. And there's a bubbler line that runs out into the wetland where we actually monitor the hydrology. There's a transducer that measures the resistance for the bubbles coming out of that thing, and that develops the data for what the water levels are. That's just the interior of the control panel. There's the bubbler system. There's a data logger. We're collecting data. Is it every 15 minutes, Steve? I can't remember. It's every 15 minutes we collect a data point. We don't have to be too fine for our purposes here. We download data twice a year, go out and maintain these boxes. There are other setups that we can use that are cheaper. This is a fairly expensive installation. There are some other setups that we can use that we're considering for the future wells, but these are the wells that we have installed so far. So I kind of like to end with this slide, and I talked about the lack of hydrology data. This, for wetlands, this is a screenshot of some hydrology data for the Little Fork River. And as you can see, it goes back all the way to 1912. We have over 100 years of hydrology data for streams, and for many lakes, it's the same kind of thing. It's unfortunate that we didn't start doing the same thing for wetlands way back then. Of course, they weren't quite as appreciated as they are now. But it's, kind of better late than never to get started. So we're hopeful that we can begin to start collecting data from these wells that we have out there. As I mentioned earlier, it might be some time before we have enough data to begin to implement that target hydrograph approach, at least using empirical data. We have talked about just getting some wetland people together in a room, and based on collective expertise and some data that we do have, we could begin to develop some of those target hydrographs and begin to implement that. But unfortunately, we need to begin to collect the long-term data to do a really good job of that. So I think that's the last slide that I have, so I'll be happy to answer any more questions.
All right. Any questions?
Yes, sir.
I have a two-part question. So as the data is coming in from working on the target hydrographs and your ability to predict the amount of allotment that these agriculture farms can pull, are you going to do it on what's your goal to do it on a 5-year allotment, or every next year, like a deer tag sort of thing? This next year you can get 15 inches?
That's a good question. We have not fully thought this through. I mean, this is not a fully baked proposal at this point. I would guess that the appropriation permits have to be renewed from time to time, and I can't remember what the time period is. But I would guess that as they are renewed, we would take a look at, what's their appropriation, what's around them, and we would base their new appropriation amount based on, what our modeling and what the target hydrograph would show. If we're seeing impacts on a wetland that is outside of what we would have expected, we have the ability to go back and reevaluate. It creates, as you can imagine, there's a lot of controversy when you're messing around with people doing their irrigation, and so it's not something that we revise willy-nilly. But that's a good question, and I don't really have a good answer for that. I think we kind of have to think some more about that and decide on what's the time period we want to apply that. So yeah, you had more.
Yeah, the thought was kind of perfect. So the conundrum being that in the dry years where the wetlands may be most susceptible to harm is also when the farmers
Need to water the
most
most.
water.
Yeah.
What are some of the opinions you're hearing from the agricultural stakeholders?
Yeah. Well, the bottom line is that the laws say that we're not supposed to harm ecosystems. We're not supposed to wholly or partially drain wetlands. So they're probably not going to be terribly happy about us shutting them down. But on the other hand, that may be a circumstance where we have to pick between sustaining these surface waters or allowing that irrigation. So I don't want to be glib about what that argument might look like, because it would probably be a very interesting debate. But the law clearly indicates that the DNR, it's our responsibility to protect those resources. I should also mention, we've talked about wetlands here today. We have the same issues with streams, and we have the same issues with lakes. And so again, the same arguments will apply. And we already had some really knockdown, drag-out battles for some stream drawdowns as a result of appropriation. So that's what we get paid to do, is to engage in that and try and find a way through it. Yeah.
So you said now you guys are like scoping out different wetlands
Yeah.
for like your reference. I would imagine for the wetlands that have been altered, that the green zone and some of them probably has been narrowed. How is that been accounted for? How will that be accounted for?
Well, the ones that we have looked at so far are ones that probably would typically have a fairly variable range of water conditions, okay, particularly deep and shallow marshes. Wet meadows may be somewhat more narrow. But the data will be what it is. We'll collect the data that says here's what the hydrologic conditions are in these wetlands over a long period of time, hopefully, and whatever the target hydrograph ends up, that's what it is, and that's the value of doing this. It gives us an objective basis for saying here's why we're limiting you in terms of your groundwater appropriation, because this wetland cannot sustain much of a drawdown before you alter the fundamental character of that wetland. So does that answer your question? I'm not sure.
Kind of. So like ones that have already been altered, since their zones might be smaller, but you're probably comparing them to the reference one, then it's just going to continue to be altered.
Oh, I
or-
see what yes, I see what you're saying. Yeah, for ones that, where we're applying the permit to ones, I think we would probably we'd have these target hydrographs that says, okay, for a wet prairie, here's the tolerances that it can sustain. If we've got a wet prairie that's out there on the ground, even it may be already affected, and somebody has got an irrigation permit for it, I think we would apply whatever that reference thing says. If it turns, if we find out that that wetland is already on the edge, say to speak, we could adjust that. But again, we probably begin with what that objective, range shows that wet meadows or wet prairies can sustain. So again, that's a good question. As I said, we're kind of in the early phases of figuring out how this will work. So Yeah, good point. Sue, you have a question?
So I have a question not about your method, but more just about what you're seeing in groundwater gas. What I'm curious about is, are you seeing anywhere yet where got pattern tiling intersecting with groundwater permitting, thinking about, climate change causing sort of a changing distribution of rainfall? I'm just curious if you see it, and I'm not going to ask if you figured out what to do.
Yeah. I know it's out there. I mean, I know there's places out there where you've got all those things going on. I can't tell you, because I'm not involved in the actual permitting end of this thing, and so I don't know that we've seen that particular thing where we have tried to take into account all of those. So
Or even being aware of the kind of, if that's beginning to kind of merge on the landscape.
yes, I think we're aware of that, and I think our permitting people are aware of those things. Like you brought up the pattern tiling, so that's having some effect on the whole hydrology of that superficial, well, even deeper aquifers, but it's having an effect on the whole hydrologic system. So how does that affect, even wetlands that are farther away in the landscape? So I think we're aware of that. I don't know that we have a very good handle on how to deal with it, though.
Just to pattern tiling isn't permitted, right?
No, at least not by the DNR. There are some watersheds watershed districts that permit it, but not by us.
Do you know what proportion of irrigators have a budget or keep account of the water that they pump?
They are supposed to keep a record of what they pump. And now this is a little bit out of my wheelhouse here, because again, I'm not involved in the actual permitting. My understanding is that they are supposed to keep track of the amount that they pump. I think there are different levels of compliance with that. I know that we are installing, in some cases, meters on their wells that can be read via radio, so that we get a better handle on what they actually are pumping. So there is this whole issue of compliance that comes into how we regulate, and that's a good point. Yeah. Yes, sir.
So talking about tiling, the scope and effect rule, is that a NRCS rule? Where you can't change the hydrology of a wetland with the drainage tile,
Yeah.
or with the ditch or something?
Yeah. Yeah. It either comes into play through the swamp buster provisions through NRCS. In some cases, it comes into play, though, with Wetland Conservation Act, the state law that protects wetlands. Again, you saw you can't drain wholly or partially wetlands, and that would include those scope and effect type things. Now, sometimes it's hard to, prove what's going on, but that can come into play, the state law, and occasionally the Clean Water Act can also come into play.
But
There.
that's not enforced through the DNR, the scope and effect.
Not through the DNR. Typically it is the NRCS, but again, the Board of Water and Soil Resources, which administers the Wetland Conservation Act, or the local government, in many cases the Soil and Water Conservation District, is enforcing that part. Yeah.
So I have another question.
Yeah,
That is,
absolutely.
you said there's 14 million acres of wetlands. Those are the existing wetlands, or are those in the wetland inventory, the ones that have been drained?
No, those are existing wetlands as of 2009, right? Is that, when do we collect the imagery?
Well, the answer is it depends.
It depends.
But the range of dates are typically for the imagery of 2009, 2014.
And there's probably twice as many. I mean, double that amount that used to be.
Yeah.
Right? About 25 million acres.
Yeah, we always say that we think we've lost about half the wetlands in the state. It's kind of hard to measure that, but about half.
Next question right here.
Yeah.
Have you done any work or any conversations with any of the tribes there, the wetlands in their reservations?
Well, the NWI update was included all the reservations. So that was a statewide thing. We have not talked with them on this aspect. We've consulted with them on a number of other projects that I've been involved with, mostly on sort of the policy end of things, but not on any of this stuff so far.
Some conversations with Pond Act, and then also some of the preliminary sites that we were looking at, but we haven't got to potential wetland. And there was a
Okay.
wetland site on White Earth, I think, as well.
Right. This is Steve Cleaver. He's also a DNR employee. He was actually managing this project, the wetland hydrology monitoring project, until he had the gall to leave and take another position in the DNR. But so Steve knows a lot more about some of the stuff than I do.
Now I do lakes, so
Now you
I
do
have to
lakes.
look deeper.
Yeah.
Could you see a scenario where sort of like the wetland banking system replaced wetlands, but it was used to swap current agricultural land into wetland sites that could be used in those dry years that were allotted to be changed within the zone of the question?
It's a good idea. Send me an email. That's we haven't thought about that, but you know, when it comes to finding solutions that are, I hate to use the word win-win, but it's good to find solutions where it's not a total win-lose kind of thing. And so that's a possibility. The other thing is that if it turns out that we could, even if we know there's going to be an impact on that wetland from the agriculture, irrigation, or whatever, we could say, well, we're going to go ahead and give you a permit, but you've got to restore a wetland someplace. So it would be permanent. We would have to have a permanent restoration. We wouldn't want to be, swapping back and forth depending on. But that's a possibility, and the laws would allow that. Yeah, it's feasible that we could look at something like that.
Could you go back to the slide that had the actual written verbiage of those laws, statutes? Thank you. So what stood out to me was the second clause in the second bullet, unless replaced by actions that provide at least equal public value. What kind of havoc, let me put it this way, do you see a clause like that ever guiding your work when you're doing this kind of?
Well, there's a long history here. I could probably give a whole nother talk about this, but this statute used to say wetlands must not be drained or filled wholly or partially unless replaced by restoring or creating wetlands of at least equal public value. Okay. And that was the direction we lived off of for 20 plus years. Not too long ago, we actually changed it to say actions that provide, because, and this is a longer answer you're going to want, but most of the wetland replacement that we get is through restoration. Okay, so there's a drained wetland out there somewhere. Somebody goes in and busts the tile, blocks the ditch or whatever, and we restore that wetland. And that's the vast majority of replacement that goes on. In the northeast part of the state, where we still have nearly all of the pre-settlement wetlands still exist, we've not had the level of drainage in the northeast as we've had in the rest of the state. Those restoration opportunities are very limited. Okay, so it's hard for somebody to find a drained wetland in Cook County that they can restore, but they have lots of wetlands to impact. You can't turn around without impacting a wetland up there. So one of the things we looked at and we ultimately decided on was we would allow some other activities like preservation of at-risk high-quality wetlands as replacement. We actually are looking at restoration of streams, and more specifically, restoration of a riparian corridor, they would include stream restoration as wetland replacement. So that's why we changed this to actions. So there's a lot more guidance that goes into this than just that. This is not, it doesn't open up the entire world. Like, you can't put a park bench out there and say, well, I've taken an action that, yeah. So, but that's a very, very good question. It can create havoc if we weren't careful. Yeah. Yes?
You were talking about not having enough data to get your reference, and so you have to do a new model. Is there any way of using remote sensing techniques to trace back your hydrograph history? Like, I think you have done that for the I don't know.
My initial reaction, and I'll let Steve think here while I'm just blurting stuff out here, but my initial reaction is it would be challenging because to develop those target hydrographs, we really need to know what the elevations of the water are, you know, relative to ground surface. And I'm not sure that there are many remote sensing techniques. Radar might be able to give you some of that, but I'm not sure it's fine enough resolution. I don't know, Steve, if you got any thoughts about that.
Yeah, there have been some cases, Canadians have done some stuff with radar interferometry. They look at multiple passes of radar and get elevations from that. So there's some potential, but it's not a complete replacement. It's not, I think it's not an either or, it's a both and sort of situation. Really, we're talking about, really, when you think about it, it sounds like a lot maybe in some perspective, but 60 monitoring sites really is nothing. Think about how many groundwater observation wells we have in the state. Thousands. You know, lake level monitoring, stream gauges. So I think we need those, even if we were going to pursue a remote sensing, which would actually be an awesome thing to do. Follow it up with a remote sensing hydrology assessment to extrapolate, but having those 60 points where you actually have the high frequency, high temporal frequency data would be really helpful. You don't get that's the other thing, you don't get satellite overpasses all the time. They only occur, you know, I don't know how frequently, you know, Sentinel-1 is a radar one that comes by, like, what, every 8 days or something like that. So for some wetlands, potentially, yeah. But you know.
Good question.
If there were, you know, other entities like watershed districts that wanted to participate with you and help you collect data, do you have any guidelines for them on how to set up monitoring systems?
We can certainly tell them.
Okay.
Yeah, and we are actually cooperating right now with the U.S. Fish and Wildlife Service. They have some wells out there and some wetlands on their land, some of their waterfowl production areas. But any entity that is willing to participate, we'd be happy to have them come on board. And I don't want to say that there's no data out there, like the Anoka Conservation District has been collecting wetland water level data for many, many years. And so there are other sources of information that we can, and we are in the process of kind of, you know, gleaning stuff off of that. But yeah, we'd be thrilled to have others participate. And
there are some public guidance documents from both Bowser and Army Corps of Engineers in terms of methodology for doing this, and that's what we're basing a lot of what we're doing as well. So there's their already written guidance out for us. And as Doug said, there actually has been some other monitoring that's been done. Anoka Conservation District, Marcel Experiment Station, USGS. What's the Glacial Ridge? Yeah. Glacial Lakes.
Glacial Ridge.
But I think they lost their funding, so they've discontinued their wetland hydrologic monitoring. USGS did. But the reason that guidance document was written was for Bowser's wetland banking monitoring. They actually have to monitor the hydrology hydrology of stored wetlands to ensure that they're actually meeting the target hydrology to get the credits, the functional credits that, for the replacement programs. So that's another application of the having a reference data. We can compare that for restorations. So Bowser and other folks have done a lot of monitoring wetland hydrology on restoration sites, but there really isn't a lot of that stuff available for reference quality studies out there.
Bowser being Report of Water and Soil Resources people. Yeah.
Great.
So,
I can
yeah.
take one more question if anybody wants to ask it. Thank you very much, Doug.
All right, thank you. Good questions.
Something up here.
Yeah, you, when you do it, stop.
Close up. I'm gonna close this browser up first. Check this out.